Hey physics fans, today we're talking about TP 6-70. Now, when reading question 6-70, it's talking about the bicyclist on a curved path, he's not leaving the path, there has to be some sort of centripetal force keeping him on the curved path. Therefore, we know we're dealing with centripetal force, we know we need to deal with Newton's second law and that type of problem, and radial acceleration. Now we have to identify our task. Our task is to derive an algebraic solution for theta, which is the angle in between the cyclist and the normal force. So, what are our givens? They give us tangential speed and the radius, and we have to assume that there is no skidding. Now, we need to solve this problem. In order to do that, we need to first take our bicyclist and isolate him, right? Then after we isolate them, we need to draw and label our external forces. We have the normal force, the static frictional force, and the weight due to gravity. Then we create our axis, which is one axis in the radial direction. The y-axis is in the y-axis. Now, let's separate and sum up all the forces in the y direction and in the radial direction. So, in the y direction, it's pretty simple. We have the normal force subtracted, and you subtract the weight force. It's just negative, right? Because it's pointed down and my axis positive is pointed this way. Then we sum the forces in the radial direction and we get just the force due to static friction, which has to be our centripetal force. It has to be what's keeping our bicyclists on the path. Okay? Now, in the book and in my free body diagram I have here, when I combine the normal force with the static force of friction, I get a resultant F. Well, that resultant F is the angle theta from the normal, and that's the angle we're trying to solve for. So, that using SOHCAHTOA, we see that tangent of that angle theta is equal to the static force of friction divided by the normal force. We throw these equations together, and we get that theta is equal to inverse tangent of our quantities here. Now, next thing they asked us to do was evaluate. Now that we already have in our algebraic expression, we substitute and evaluate. We get theta is equal to 26.1 degrees. We do a quick check. Is that reasonable? Yep. It's not going beyond 45 degrees. It's not falling down at about 26.1. That's reasonable. Sig figs, 3 sig figs. 26.1 degrees is not necessarily a SI unit, but when I measure theta, theta is usually measured in degrees or radians. So we chose degrees. All right, that's it for TP 6-70. See you next time. To the window, to the wall. All these problems solved. All these problems